Hello everyone, my name is Teman. I'm with the Ethereum Foundation, product manager, focusing on ERC 4337, also known as Account Abstraction. In this short video, I'll be going over what is Account Abstraction, what's the architecture like, and what can we do with it, what's the benefits. So let's jump in. So I think the first question that comes to mind when talking about account abstraction is, why do we call it account abstraction? What are we abstracting exactly, and why do we do that? So to answer that, I think first we have to talk a little bit about EOAs. So EOAs is externally owned accounts, and that is what we all are familiar with from regular wallets. It's a signer and an account bundled into one, where it's your public key and your private key, where your address is derived from your public key, and your private key is used to sign a transaction. Now, while this system is very simple, it also has a lot of problems and challenges due to its simplicity. And the first one, which I think everybody sadly is probably familiar with, is the fact that it's just one key, and if it's lost or stolen or something happens to it, that's it. So if your key is compromised and you want to rotate your keys, that is not something you can do. You can, but that means you have to start off with a brand new account. When we're talking about blockchains like Bitcoin, this is not that much of a challenge. There's not really such a big problem with moving your Bitcoin to a new wallet. The problem is, when we're talking about Ethereum, is that a lot of times your wallet address, which is linked to your account basically, means that you now have to go to all the different contracts that you interacted with and let them know in a way that you are now using a different account, which is not always possible. There could be all kinds of time locks or limitations that don't allow you to actually change your address, and which means that you are kind of in a problem. Your account is lost, which means that everything that account is linked to is now lost, with its reputation, permissions, everything that you might have, staking, etc. And additional with EOAs, there's no granularity in what your key can do. It's usually one key that does it all. That is also something which is very challenging from a UX perspective. Additionally, gas payments. You gotta have some ETH on the account that you're using to sign transactions. Again, with Bitcoin, not usually a problem, because if you want to move Bitcoin around, which means you already have Bitcoin. With Ethereum, this isn't always about money. This could be about permissions. You want to use a DAO, you want to sign with some key. You don't necessarily want to hold any ETH. The fact that you gotta have ETH to begin with in that account creates painful onboarding and also privacy issues. That means that usually that ETH you send into your account is from some sort of like centralized exchange or some other doxed account, which means that if you want to participate in a DAO, in a way you gotta expose who you are. You want to claim an NFT, you got to expose who you are. That creates a lot of privacy issues. And for dApps themselves, EOAs are also very limiting. Batching transaction is not possible. There's no type of automation you can do. I want to have my account listen to things that happened on chain and automatically do stuff. The only way I can do it with EOAs is to give away my private key to some sort of centralized server, which will listen to those events and sign on my behalf, which, that's just asking for trouble. So what do we mean when we say we are abstracting? So with account abstraction, we are basically creating this layer in between. We're using a smart contract to manage your account, which means that just like in the regular world of Web 2, where you have all types of permission layers in place, we are recreating that on the blockchain, but in a way which is decentralized. That's an important element here, which means that if you set those permissions, you don't have to rely on anyone to enforce those permissions that you set for your keys. They're automatically enforced by the contract code, which means they're unstoppable, uncensorable, no single points of failure, etc. What are we abstracting? So when we're talking about using private keys, it's very well known that you usually have two parts, which is the authorization and authentication. So I'll start actually with the authentication. Authentication is asking, is this key valid? is this signature valid, the signature itself. That's the authentication that we all know. The other part is the authorization, which is sorely lacking in EOAs, which is saying, what can this key do? Right now with EOAs, the authorization is, well, everything. But we're used to having, roles like an admin, user, moderator, whatever, which each can do different types of permissions. By adding this smart contract code in the middle, which is the user's account, then we can add those validation rules and have this authorization set of permissions. So we're abstracting away this layer, allowing users to have that power where they can have different keys, do different things. That's the validation part. And the other part is the execution itself. We can do more sophisticated types of execution if it's batching transactions together, which is a very common use case, for instance, with DEXs, where you first have to approve, then you have to, send some tokens, then you have to do the actual trade. This can all be batched into one transaction, which provides a lot of benefits, both from a user perspective, like user experience perspective, but also from the perspective of allowing you to have better security, in a sense. You don't worry about things changing between the different transactions being included in different blocks. It all happens in a single block. That also offers a lot of power. In addition, you can have automation. You can allow your contract to basically have hooks and stuff of that nature, which will allow greater power. You can look, for example, you can look at trades happening and automatically copy those trades, just like one example. Finally, and this is also a big benefit, we're also abstracting away gas payment, which means that you can allow third parties to either completely sponsor your gas fees, or they can accept other tokens like USDC or any type of token they want and sponsor your gas payment. A common use case we see, for instance, is allowing anybody who owns enough tokens of a specific DAO for governance. The DAO itself will use its treasury to sponsor any votes you carry out. So the gas payment sponsorship, which is done through something called a paymaster, which any third party can implement. It's just a contract that hooks into how this whole ERC 4337 account abstraction works, will allow them to look at your transaction. Oh, it's interacting with the contract of our DAO for submitting a message that you signed or whatever, and your contract holds enough tokens in our ERC20 contract. Okay, in that case, we'll sponsor the gas fees, and that user doesn't even have to hold any ETH, any USDC, nothing. They just need to hold tokens of that DAO, which is reducing so much friction for those users. Now, account abstraction is something that has been on the core devs' mind since the beginning of Ethereum. Sadly, it was not included in the initial version of Ethereum because, well, you know how code is. You got to deliver quickly, and Ethereum had to deliver the first version, and account abstraction was not included. Several EAPs, which was introduced throughout its history, which will be included in the documentation. There's a couple of interesting talks about how, if you're interested on how that history plays out. The challenges were without those EAPs is that they required changing the core protocol of how Ethereum works. And when you're not talking about something like performance or gas fees like EAP 1559 or the merge or stuff like that, those type of EAPs, it's easier to convince the core devs of their, that they're solid and good and should be included, because making hard forks is something that we try to be very careful about. So here we're talking about something which is both security and usability, which are two sides of the same coin in essence. So when you're talking about making those changes, it's very hard to do a hard fork. So the smart part, the interesting part about ERC 4337 is that it's an ERC, not an EAP. For those unfamiliar with the difference, EAPs are breaking changes, like that from regular coding experience. It means that at some point, once that EAP is implemented, there's usually some time period, but after that time period, it's kind of like you're either with us or against us, meaning it's like if you don't want to follow this EIP, you got to fork into your own chain and do your own like Ethereum Classic 2, whatever, and don't include that EIP. That's fine. You're welcome to do that, but we're moving on in that direction. ERCs are non-binding in that sense. It's more of like we all agree around the standard because we see the benefit. For instance, and this is the most well-known ERC, ERC20 or ERC 721, which better known as NFTs. You don't have to follow what an ERC20 is. There's a lot of value there. I don't think we would have seen DEXs flourish as much if we didn't all agree that, okay, when we're talking about fungible token or non-fungible token in the case of NFTs, that's the interface we all agree on. This is what it should include. If everybody implemented their own version of ERC20, it would have been a problem to have this, building on top of building on top of building of other stuff that people have built. So ERC 4337 in that regard is non-binding. If you include it in how you architect your new wallet and everything else, great. If you don't, the network still works the same. Disclaimer, sometime in the future, we are planning to have this as an EIP, as a breaking change. It will offer a lot of benefits in terms of performance and security and other kind of elements. The idea is also this will not be a breaking change for anybody who already implemented ERC 4337. So if you're a wallet or a bundler or anyone else who is working on supporting ERC 4337, once this becomes an EAP, it will require close to no changes on your end to still work the same. This is very important because we don't want to penalize anyone who's already working to implement this. So what is ERC 4337? So first of all, we get full account abstraction, which I already explained, so I won't go into that again. ERC 4337, as opposed to other existing account abstraction solutions, is fully decentralized, meaning that it's censorship resistant. To better understand this, keep in mind, the network still works the same. When a transaction is submitted on-chain, it still needs some sort of EOA. In this case, the EOA will be owned by what is called a bundler, which I'll explain in a minute. But current existing account abstraction solutions usually have a centralized relayer, which means that if that relayer is somehow, it could be censored, it could throttle you, it could be seized by the government. There's all kinds of problems that we don't like in the world of Ethereum around centralization. So it's very important that things are completely decentralized while having DOS resistance in mind. So that's part of the architecture of how ERC 4337 works via bundlers, which we'll explain in a few minutes. And speaking of the bundlers, we're also very adamant about having a robust infrastructure, which means that there are currently quite a lot of bundler implementations out there, around 7 or 8, I'm not sure. The links to all the existing bundler implementations will be in the documentation, which we'll also include in the description of this video. So you can click on that and check it out on our Notion page. And that means that there's a lot of implementations of how bundlers work. Think of bundlers a little bit like block builders, which they are in a sense, and how ERC 4337 works, okay? And finally, which I mentioned, there is no protocol change. It's very easy for every chain to add support for ERC 4337 and doesn't require any consensus from everyone else. If you want to learn more, there's also our official website, erc4337.io. Go check it out. There's a lot of useful resources there as well. So when we're talking about ERC 4337, there are 6 main components. First of all, there's the account contract. This is the user's smart account, if you will. That's their smart contract, which includes their validation logic. Right now, a transaction will have 2 parts. Currently, with EOAs, there's just one part of the validation, which happens as part of the protocol itself, which is EC Recover. Is basically looking at the transaction and seeing that the public key matches the private key, and that this is indeed a transaction by the user. When we're talking about smart contracts, smart accounts, it's more sophisticated. And we said you can now have any type of key pair you want. So you have both the authorization check and the authentication check, and that all happens within the account contract of the user. The entry point contract is this global singleton contract, which is heavily audited and is part of the ERC standard. Think of it like a traffic cop, okay? To remove a lot of the work from the smart account builders, the wallets that are creating those new account contracts for users. This takes care of a lot of the back and forth that happens in terms of how the simulation of the transactions work and using the bundlers and the paymasters. And there's a lot of logic there, which is encapsulated in the entry point contract, which is what everybody is using. So the smart contract that is for the user's account can be a lot leaner and doesn't have to we're reducing that load from them to make sure that they're doing everything properly. It's all done in the entry point contract. The documentation explains this a little bit more in depth. I will not go so deep into that in this talk. The paymaster, which I mentioned, is a smart contract, which is part of the flow of how a transaction, this new type of transaction in ERC 4337 exists, which is the user operation, which you can see on the bottom left there. And the paymaster is part of that flow. And I would say there's basically two types of paymaster. The first one is a token paymaster. The other one is a verifying paymaster. So a token paymaster is a purely on-chain paymaster. That's usually the case you can think of is a paymaster that will accept USDC and pay for your gas fees in ETH. They will probably take a little bit of extra USDC to account for fluctuations in the price and also to make a profit. But this will allow a user to only hold USDC, doesn't have to hold any ETH in their account, and they can pay for gas with USDC or any type of other token that the paymaster will agree to accept. Can be all types of different DAO tokens, governance, etc., whatever they want. They can accept, Uniswap tokens, whatever the paymaster is willing to accept. Verifying paymasters are paymasters that will actually do some sort of verification off-chain and will give you this signed message, which you can think of as a voucher. That signed message is included in your user operation in this new type of transaction that exists in 4337. And once your transaction hits up the paymaster in the flow, the contract code will look at the signed message, will say, oh, okay, this is a voucher that I issued, which means I'm willing to sponsor the gas fees, and the paymaster will then pay the gas fees. How do you get that voucher? That's up to the paymaster. In the case of, for instance, Visa recently released an article explaining how they are linking credit cards into paymasters, so users can actually link up their credit card, and from that moment on, Visa will use a verifying paymaster to charge your credit card for any gas fees that you need to pay when interacting with the blockchain. So that's one option. Another option, a paymaster can just say, look, I'm just going to sponsor my user gas fees. For some reasons, I'm willing to. And that's easier for me than expecting them to have some sort of token. I prefer to have some sort of off-chain validation. Maybe I want them to, log into their Twitter account, whatever I prefer to do. And another option is, for instance, ads. A paymaster can say, okay, you're going to watch some ads. I'm going to get compensated from the ad agency, and in return, I will give you that voucher, which will then sponsor your gas fees. So, there's a lot of things you can do when you're doing off-chain validation. User operation. So user operation, I mentioned, this is the new type of transaction. It's like a transaction with some additional details. When a user signs a transaction with an ERC 4337 smart account, what they're doing is they're actually signing a user operation. Those user operations will then get sent to this new type of mempool. This is how we can have ERC 4337 be an ERC and not an EIP. We're creating this new type of mempool, which the bundlers then look at. The bundlers are the block builders in this ecosystem. So what a bundler will do is will take a lot of user operations from the mempool. It will validate them. I will very soon show you how that works exactly. It will validate that those transactions are okay. And when I talk about validation, I'm not talking about the actual payload of what the transaction does on chain. I'm talking about the first part, which is the authentication and the authorization. And any other type of rules the user has in their account contract, which dictates what their account is allowed to do with each type of key that they link to that account, because you can have different keys linked to the same account. That's that's a big part of the flexibility we're gaining here. So the bundler will do that validation, and if everything is fine, they will actually take all those user ops, put them inside a big old transaction, and then they will not, and this is an important note, the bundler will not submit that transaction to the regular mempool. No, they are actually block builders. They will add that transaction and submit it as a proposal for the next block themselves. Otherwise, they could get front run and all kinds of other shenanigans. So bundlers, you need to think of them as block builders, okay? So how does a user operation lifecycle look? Okay, so on the green square here is some sort of smart contract wallet, okay? So it all starts with the user signing using whatever key logic they have. They sign this user operation. The user operation then by the wallet gets sent to this user operation mempool. Same way that a regular transaction gets sent to the native mempool of the blockchain. In this case, there's this new type of mempool called a user op mempool. The bundler then picks up this user op mempool and goes through the flow of validating it through the entry point contract. So how does that look? So first, they will simulate the user op. Okay, we do the simulation phase. It's like a dry run. It's like you're only using view calls. You're not actually writing anything to the blockchain. So they will call simulate user op on the entry point contract, which in return will call the user's contract account and validate that user op, and also validate a paymaster user op if needed. If everything is okay, then we go to the execution phase, which is handle ops. In that execution phase, the user's contract account will again validate the user op, but this time we'll do it on chain. This is when this will happen once that transaction is actually as part of the block and it's getting run by is getting executed on chain. So there's the validation, and once the validation is correct and the authorization authentication is valid, then the execute will call, which will actually do the transaction, which is, let's say you want to do a trade, you want to vote on something on a DAO, any type of the call data itself. Because keep in mind, the validate user ops is about making sure that those keys that you used are allowed to interact with those contracts, those methods, whatever permission logic the user account should have. The execute is the actual payload itself of the transaction, what you're actually, writing on chain. And assuming everything is great, then, the transaction went through. So there's a lot of developer platforms which you can use. And another video as part of this series will be by the Garvit, who is an Ethereum fellow that developed Trampoline. Trampoline is what we built for developers that want to hack around ERC-4337 and want to use their own specific contract code and want to be able to tinker with it, so to speak. So, but if you want to later on build something that is more, let's say, production ready and a lot more sophisticated, then you can use any of those developer platforms. We're going to have a link in our documentation. They will limit you in what you can do. The idea behind Trampoline, which you will also have a link to in the documentation, is that you can do everything. It's a MetaMask clone using React, and it's an extension that you install, and it easily lets you change everything in the flow and how your user signs transaction, etc. So if you're doing something sophisticated, which I assume you guys are, I would recommend you use Trampoline. But if later on you want to build something that is, more more UX friendly, more for the mainstream, etc., then I would suggest looking at those developer platforms. And if they don't offer what you guys need exactly, and you need a little bit more of a customization, then just reach out to those teams. I'm sure they will be happy to help you out and see what they can do. So again, these links are all going to be appeared in our documentation. We have a Telegram group for our Trampoline builders, and we're very happy to answer all of your questions. And we're excited to see what you guys are going to build with ERC-4337 and Account Abstraction. Thank you very much.